The category API lesson had a lot of code and brought a lot of new concepts together. This lesson on the product API will be a bit less of a stretch because the product API is pretty analogous to the category API. The routes are going to work pretty similarly. For instance, when you visit this /API /v1/product/id/ big MongoDB object ID string, this API endpoint will load a product by its ID. In this case, the product happens to be an LG G4 phone. There are two new files in this lesson. There's this product.js file and the fx.js file. Let's take a look at fx.js first. The fx.js file contains the same fake exchange rates that you saw in the Mongoose schema design chapter. The product.js file contains the product schema that you defined in the Mongoose schema design chapter. Recall that the product schema has some basic metadata about the product, like its name, its list of pictures, and, most importantly, the category that it belongs to. This index.js file, the entry point for the web server, hasn't changed from the category API lesson. You use the same files, models.js and api.js, to bootstrap the web server. The models.js file has changed a bit, because now there's two models instead of one. The new product model is created here. The code that registers the services has changed a little, so you don't have to write a separate Wagner.factory call for every model. This uses the each function from the underscore package that you saw in the introductory chapter. This ensures that our code stays dry. DRY stands for don't repeat yourself. Let's take a look at the api.js file, which is going to define the route handlers for the two API endpoints for this lesson. There are two get routes here. The first one loads a product by its ID, and the second one loads its product by its ancestor category. The route that loads a product by its ID is pretty trivial. The only major difference between this and the route that loads a category by its ID is this handle1.bind thing that you're using as a callback. Now, the bind function is a powerful JavaScript tool for reusing code. Let's take a look at the handle1 function. Here's this handle1 function. Notice that it takes four parameters: a property name, a express response object, and then an error and a result. These error and result fields come from a find1 call. So handle1.bind returns a function. When you call handle1.bind with these three parameters, the first parameter is the value of the this variable in handle1, which you don't use in this example. The second and third parameters, product and the express response object, become these first two parameters to handle1. For instance, ask yourself, what will this simple program output when you run it in Node.js? When you use test.bind, you pass two parameters. The first parameter becomes the function's this, and the second argument becomes the first argument in any calls to the test with p1 function. So when you run this program, you will expect to see a JSON object followed by first parameter, this, and second parameter from this, which is in fact exactly what you get. As a consequence, this handle1 function can now define generic rules for handling results to calls to model.find1. So in which case it treats these errors as internal server errors. If there isn't a result, it returns the not found. Otherwise, it returns the result. Similar to how the category API's find by ID route worked. Now let's take a look at the second API endpoint. The second API endpoint returns all products that belong to a given category, including its subcategories. For instance, if you ask for all products within the category electronics, you will get phones as well as laptops. As per your category schema design from the schema design chapter, you get these products by searching for all products whose category ancestors array contains the given category. This API endpoint has one additional caveat. The user can specify if they want the product sorted by price. For instance, when you navigate to /API/v1/product/category/electronics, you will get back the products ordered by name, in which case the Asus ZenBook Prime comes first, and the LG G4 comes second. But if you specify price equals 1 in the query string, you get the products ordered by lowest price first, in which case the LG G4, whose internal.approximate price USD is 300, comes before the Asus ZenBook Prime, whose internal.approximate price USD is 2000. The logic that accounts for that is this particular block. It assumes that it will sort by name first, but if rec.query.price is equal to 1, it will use internal.approximate price USD ascending, and if price is -1, it will use descending. Remember that approximate price USD is a property that we keep with a custom setter that keeps track of what the approximate price of the product is in US dollars, so we can have a consistent sort order. Now let's take a look at the code that tests this API. The bootstrapping code is absolutely identical. The test for the route that loads products by ID is pretty analogous to the category API tests. First, you create a product, which is the LG G4. You create it in the database, and then you use SuperAgent to make an HTTP request to product ID and the ID corresponding to the LG G4. And you assert that you get back the correct product. The test for the route that loads products by category is more complex because it needs to create a bunch of data. So you're going to create 4 categories: electronics, phones, laptops, and bacon, and phones and laptops are child categories of electronics. You're also going to create 3 products: the LG G4, which is in category phones, the Asus ZenBook Prime, which is in category laptops, and finally some bacon, which is in category bacon. You'll create each of these categories and products, and then make an HTTP request to product category electronics using SuperAgent, and make sure that you got back the ZenBook Prime followed by the LG G4 when you don't specify the query.price parameter. Finally, you're going to test that when you specify price is 1, you're going to get the products sorted in ascending order by price. So when you make this HTTP request with SuperAgent, you're going to get back the LG G4 followed by the Asus ZenBook Prime.